Welcome to subtopic 2.2, the mass spectrometer. The mass spectrometer is a vital instrument in many kinds of chemical analysis. But how does it work, and how do we interpret the data that we get from it? A mass spectrometer works in 5 stages. First, the sample is vaporized. Then, it is ionized. Third, it is accelerated. Fourth, it is deflected. And fifth, it is detected. The deflection stage is the heart of the mass spectrometer. When we accelerate an ion, it would like to keep moving in a straight line. This tendency of the particle to move in a straight line, its momentum, is proportional to its mass. However, in a mass spectrometer, we use electromagnets to try to deflect the ions off their path. The amount of force that the ion feels from the electromagnet is proportional to its charge. The path that the ion actually takes is a result of its mass-charge ratio. A different particle with a different mass-charge ratio will take a different path. And this is what we are actually detecting, different mass-charge ratios. So let's analyze a sample. If we vaporize it and ionize it, accelerate it, deflect it, and then detect it, we can record its mass-charge ratio. If we repeat this with more of the same sample, we will record different size fragments. Eventually, we'll know the proportions of all the different size.
Second part is analyzer. So the function of analyzer is to resolving the ions into their characteristic mass compounds according to their mass to charge ratio. And then lastly, the detector to detect the ions and records the abundance of each ions. So for the basic principle of spectroscopy that I know is first, mass spectrometry generates multiple ions from the sample. And then it also separates them into their separate mass to charge ratio. And then lastly, it records the relevance of abundance of each ion type in the sample.
Okay, so basically the process has 4 stages, which is the first one ionization, the second one which is acceleration, and the third is deflection, and the last one is deflection. For the stage 1 is ionization. First, the sample is bombarded by the electron, and then the electron run between anode and cathode. Next is the high energy electron in the stream node electron out of the sample to form the ions. Next step is the next stage is acceleration. For acceleration is a simple step where the ion placed between a set of charged parallel plates, and then the ion will be repelled by one plate and attract to the other plate. For stage 3 is deflection. For deflection, ions are deflected by the magnetic field surrounding the instruments. The amount of deflection depends on the mass and the charge of the ions. Last but not least, the last stage is detection. In the detection, when the ion stream reach the detector and hit the wire, and then the amplifier pick up on this current being created between wire and ion and amplifies the signal being detected. So that's all what I know in the mass spec. Thank you.
So for the interpretation of data, the molecular formula given was CH3CN, and the spectrum show like this. The N peak refer as parent peak, which give molecular weight of the compound, and the graph axis was relative intensity versus mass to charge ratio. So, to confirm that molecular formula is tally with the spectrum, we use rule of 13. So, before that, we need to subtract the molecular weight with the molecular weight of the heteroatom. So we subtract the value of molecular weight, which is 41, minus with 14, and we get the value of 27. And then we find the value for n by using formula n plus divide by 13. And then we get the number of carbon, which is 2. So the next step, we find the value for m by divided the molecular weight that was subtracted by the heteroatom, and we get 3 hydrogen. So the value of 1 is referred to the remainder. Oops! I forget to mention that the n is referred to the number of carbon, while m referred to the number of hydrogen. Next, I will proceed on how to find the value of m. So first, we divide the subtract value of m plus, which is 27, with 13, and we get remainder 1. So this value, which is 1, is a remainder. This remainder need to be added by the value of n that we get just now. So 1 plus 2 is equal to 3. So we get the number of hydrogen is equal to 3. So this is our interpretation of data. Ta-da! Balls that have small mass will deflect the most, while balls that have larger mass will deflect the least. When the sample is injected, the ions are vaporized to produce positive ions. Then the magnetic field deflects the ions. The ions hit a detection plate, producing a tiny electrical current, and results in spectrum that showing different peaks. Therefore, the greater the current, the more abundant the ions.